Have you ever played with Legos and thought, hey, I could build something amazing? Perhaps a house, a car, or a bridge to the moon? Sounds like a very good idea, but let me tell you, it's a wild ride. So grab your Lego bricks, we are about to build the most ambitious project in human history. The moon is almost 400,000 kilometers away, that's roughly 30 Earths lined up in a row. To put this into Lego terms, if you use those classic 2x4 bricks, each one is 9.6 millimeters tall. That means you'd need a stack for over 40 billion Lego bricks just to reach the moon, and that's not even considering the actual bridge structure. But hey, you can't just stack Legos in a straight line, we need an engineering marvel here, a proper suspension bridge in space. Something strong enough to handle its own weight, the vacuum of space, and the occasional stray asteroid, no pressure. Here's the first problem. Legos are made of ABS plastic, which isn't exactly known for its space durability. ABS melts at around 105 degrees Celsius and becomes brittle at minus 20 degrees. In space, you're dealing with temperature swings from plus 120 degrees Celsius in the sun to minus 180 degrees Celsius in the shade. Your Legos would turn into gooby globes or shatter into cosmic confetti. So we would need to coat every brick with something space resistant like a thin layer of titanium. But hey, titanium coated Legos, how cool is that? Now let's talk about numbers. Each Lego bricks weighs around 2.5 grams. Multiply that by 40 billion bricks we need and you are looking at 100 million metric tons of Legos. That's the weight of 15 Great Pyramids of Giza. And how do you get all those Legos into orbit? Well, at around $2,700 per kilogram for a space launch, shipping them would cost a staggering $270 trillion. But wait, there's more. Even if we somehow got all those Legos into space, we would need to worry about structural integrity. ABS plastic has a tensile strength of about 50 megapascals. That sounds impressive until you realize the gravitational pull between the Earth and the Moon would stretch our Lego bridge into a string of floating debris. So you would need to reinforce it with steel cables or carbon nanotubes, material strong enough to handle the immense forces at play. Fun fact, did you know that Lego makes about 36 billion bricks every year? That sounds like a lot, right? Well, if we hijack their entire production line just to build our moon bridge, it would take just over a year to stack Legos from Earth to the moon. Now let's say we somehow solve all these problems and actually build the bridge. What would it look like? For starters, a suspension bridge in space would need a massive anchor points on both Earth and the moon. But here's the kicker, the moon isn't stationary, it's orbiting Earth at 3700 km per hour. That means our Lego bridge would need to stretch, contract and flex constantly to account for the moon's movement. Add in the sheer length of the bridge, almost 400,000 kilometers, and you are dealing with stresses and tensions that make even the strongest material seem like a wet paper. And don't forget, the Earth's rotation adds another challenge. While the moon is orbiting, Earth is spinning on its axis, dragging the lower end of the bridge along for the ride. You would effectively be building a giant cosmic tug-of-war between two celestial bodies. In short, keeping their bridge intact isn't just unlikely, it's downright impossible. So, could we build a Lego bridge to the moon? Sadly no. Between the extreme temperatures, the sheer weight of the materials and the relentless forces of gravity, the dream of the Lego moon bridge crumbles faster than a poorly built Lego tower. The cost alone would bankrupt humanity several times over, and that's before we even consider the physics of connecting a moving moon to an Earth. But hey, that doesn't mean we can't dream. After all, it's wild ideas like these that push humanity to think bigger, even if the answer is resounding nope. So next time you pick up a Lego brick, remember, while we can't bridge the gap to the moon, we can still build a universe of imagination right here on Earth. Thanks for watching, like, comment and subscribe for more mind-bending thought experimentals.